number 1, you needed to find your slope. So you would take your y values, subtract them together, then your x's and subtract them together. So 1 minus 4 and 6 minus a negative 3. You get negative 1 over 3. Any questions on that one? Number 2, I know it's been a minute. Go to class.
How?
Go to class.
Right now?
Yes, right now.
I got some later today, right, Caleb?
Yes. Number 2, you needed to find the slope, but you needed to remember your quadratics. So horizontal lines have 0 slope, and those are y equals. Because our line is y equals, our slope would be 0. You could have also graphed that and figured that out as well. Questions on number 2? Yeah.
Say what?
Say that one time.
Say what?
Y0. So this is something we talked about earlier. This, I don't know if that's the right word. Anytime you have a horizontal line, it's always going to have a 0 slope. And these things are related to it being y equals. So because it's y equals, if I were to actually draw it out, you would see that too. So this is going to be at the point when y is 3. And because the slope is not changing, it's just going to be y equals 3 all the way across for every single x. So it's a horizontal line, and your slope is 0. It's not moving up and down. The range for number 3, you're looking at the lowest point to the highest point. The lowest of this is at negative 2. It does not go lower than that, but that's where it starts. And then it keeps going up because of the arrow. So it's going to go up off the graph. The y's are going to keep getting bigger and bigger. So it's going to start at negative 2 and keep going. So you can write this one of 2 ways. Y is greater than or equal to negative 2, or an interval notation, negative 2 with a square bracket, because really there was a point there to infinity. Do you have any questions on that one? On the back. Number 4, it wanted you to write the equation of this line, so I know that was some units ago, but you needed to find the y-intercept and find the slope. So for this one, our y-intercept is 1. It needs to be in the format y equals mx plus b, and then we need to find our slope by counting. So if you count what your slope is, the next point that goes through the green line exactly is this one up here. So from your y-intercept to this point, your slope is up 4 to the right 3. So your equation would be y equals 4 over 3x plus 1. Do you have any questions on that one? And then the very last one, you needed to graph this equation. Your y-intercept was at 3, your slope was 2, so go up 2 to the right one as many times as possible, and down 2 to the left one as many times as possible. Draw a line through all of your points, make sure it has arrows, and then you would have your graph. Do you have any questions on that? I'm going to pause this for a second to make sure the sound is working before I do this. Look at your course calendar. Look at important dates, upcoming dates. So this next unit we should finish by middle of March. We'll be separating the quizzes and tests. Make sure that you know those dates. They're on the board as well. What is not on that paper is your benchmark dates. So I did just put those in the announcement. So you should see that for today when they come out if you look at that. But your benchmark days are going to be the 30th and the 31st. And then there'll be makeup days before that. But if you need to retest anything from Unit 5, so those variations, if you haven't finished that, you need to do that ASAP. Factoring, the one we just did, and then the last test that will go on this marking period is this unit, quadratics. So if you need to retest any of that stuff, you need to get your retest stuff done as soon as possible. So your test corrections, your additional practice, Khan Academy, math, all of that stuff. Come see me before or after school. We can work through any of that together. Yes, you will have makeup days, so you could do that work too, but I wouldn't wait until then. Do you have any questions on any of that? Okay. Our new unit is on quadratics. So I mentioned this briefly before. When we were factoring quadratics. We just didn't say that. So anything that has something squared is a quadratic. And we're going to deal with certain aspects of that. Those of you moving on to Algebra 2, you'll deal with quadratics more, do a lot more with them, talk a lot more about them, and all of those things. So you should have these notes. Make sure these are in front of you. So the first thing we're going to talk about is one way you can solve quadratics. When you get to Algebra 2, there'll be multiple ways. We're just going to talk about a couple. And one is using square roots. So the only way this works is if you're missing a b term. So think about your trinomial, your ax squared plus bx plus c, but you're missing the bx term. That's the only way this works. If you have a bx term, this won't work. Okay, so for this, we're trying to get x squared by itself. So we're going to get everything else away from it. How would we do that? Add 49 to the other side. Also, if you don't have your calculator, go grab it. So after we isolate the x squared, the next thing we're going to do is take the square root of both sides. So this should somewhat be familiar from when we were factoring and doing difference of squares. We're looking for what times what would give us x squared. X. And then if you aren't sure what the square root of 49 is, I'm just going to show you where the button is. It's in blue, right above x squared. So if you hit second x squared, you'll get that button. Then you can put in whatever to figure out what this is. So 7 However, yes, we just got that that was 7. What we did not talk about before is, yes, 7 times 7 will give us 49. But the same thing is also true for the negatives. Negative 7 times negative 7 is also positive 49. So when we do this, we're actually getting 2 answers, the positive and the negative. So we're going to put both. And then we need to put them as solution sets. So our final answer would look something like this. X equals, we're going to have curly brackets, and then you want least to greatest. So negative 7, positive 7, and that would be our final answer.
I don't get that.
Yeah, which part?
The part where we have to add the positive and negative.
So that part is weird because you know square root of 49 is 7, not negative 7. So you have to think about it like 2 negatives make a positive and 2 positives make a positive. That's the only reason why we're doing this. Both of them would still give you the same answer. So both would work. Do we have any other questions on that before we do some more? So let's work through some more of these. Number 1, isolate your x squared, so move 16 to the other side. And then take the square root of both sides. Don't forget your positive and negative, so that would be x equals plus or minus 4. So for all of these, we're always going to have a plus or minus, no matter what. And then our solution set would be x equals negative 4 and 4. Questions so far? This is supposed to be a curly bracket. I just can't draw one of the sides. Number 2, walk me through that. What would I do first?
Add number.
Add 100 to the other side. And then
Take the square root of both.
take the square root of both sides. And we would get positive and negative 10. And our solution set would be in curly brackets, negative 10. Great. This does get harder. I just wanted to make sure we were all on the same page with the easier stuff first. Okay. With number 3, this is not positive, so I'm going to subtract. And I'm going to take the square root of both sides. In your calculator, put the square root of negative 25. It says error. Because we can't take the square root of negative numbers. I know that's confusing because we're getting a negative answer, but that's because negative times a negative gives us a positive. But we can't just take the square root of a negative. What you'll learn in Algebra 2 is that there are imaginary numbers that go with that. In this class, we're not talking about that. So if you get a negative underneath the square root, that is not a solution. We are not dealing with negatives underneath the square roots in this class. It is a thing, just not in this class. It's not. The square root second x squared, the negative sign at the bottom, and then 25. So you would get an error. Moving on to number 4. Now we have numbers that aren't 0. We're still doing the same process. Get rid of everything near your x squared, so subtract 7. Take the square root of both sides. What would the square root of 81 be?
9.
Plus or minus 9. Negative 9 and positive 9 would be our solution sets. For number 5, if we were to solve this just like we did number 4 and subtract 7 on both sides, what happens? We get a negative. So what is our final answer going to be? Doesn't work, no solution. So when you see that negative, you don't even have to keep going. Immediately stop, no solution, it's not going to work. But make sure that your x squared is completely isolated first. Do we have any questions so far? We're going to get into some more challenging ones. We're going to jump down to 7. How would we isolate our x squared here?
Divide by 6.
Divide both sides by 6. So now we have x squared equals 9. 9 is a perfect square. Take the square root of both sides. Get plus or minus 3. And negative 3 and 3. For number 8, it has a negative, but x squared is not isolated, so don't immediately jump to it doesn't have a solution until you isolate it. Divide both sides by negative 2. X squared equals 49. 49 is a perfect square, so we can take the square root of both sides. Get plus or minus 7. So negative 7 and 7. Number 9. Now we have this 3/4 we need to get rid of. So just like in a regular equation, if we had a fraction next to our x and we're trying to get rid of it, we can do one of two things. Either divide both sides by 3/4, but then you have fractions within fractions, so be careful with that. Or take the fraction, flip it by 4/3, multiply that on both sides. In your calculator, just so you remember, I have 12. I need to multiply it by 4/3. So alpha y equals will give you your fraction. And then I can put in 4/3 and get my answer. (16) is a perfect square. So we can take the square root of both sides. Get x equals plus or minus 4, or x equals negative 4 positive 4. We'll do one more on this page and then we'll flip over to the back pattern. To get the actual fraction, alpha y equals, and then it's the first one. Number 10. Now we have two things we need to do to isolate. What would we do first? Okay, you should be getting rid of the 5 first. On a just in case, this fraction is not something like 1/2. If you multiply by the reciprocal and then everything, you would have to do that to everything. So let's say it was like something with a 3, and now you're multiplying this by something with a 3. Maybe it ends up over 3, now you have a weird fraction. Avoid that. Get rid of this first by adding it. Then deal with the number that's being multiplied. So now I can multiply this by 2.
50. It should be.
It should be equal to 50. That's all. 100 is a perfect square, so we can take the square root of both, get plus or minus 10. So x equals -10 and +10. Do we have any questions on how to do this so far? Smart. On the fraction, like how we're doing this part? Yeah. So anytime we have a fraction, in general, if you had something like this, you would divide it, right? I could do the same thing. I could divide this by 1/2, but that doesn't look very nice, right? Even though I could do this. I'm going to show you it's the same thing. So we know 50 times 2 is 100. If I did 50 divided by the fraction 1/2, you're going to get the same thing. Because what the calculator is really doing is taking this, flipping it, and multiplying it. So instead of dividing, we're taking that same fraction, flipping it, and multiplying it. This becomes 1, and what we do to one side we have to do to the other. So do whichever makes sense, divide by the fraction or multiply by the reciprocal. On the back, we're going to jump to number 16. With 16, we need to still isolate the x squared, so we will get rid of 16 first by adding it to the other side. And then dividing it by 9. Now, you're probably thinking we can't simplify 16 over 9. That's going to give us a decimal. That is true when we take the square root. But when we take the square root of perfect squares that are being divided, we do something a little different. So we're still going to take the square root of both sides. But when we take the square root of a fraction, this would be the same thing as taking the square root of each one separately. So the square root of 16 over the square root of 9.
8 over 2.
4 over 3 or plus. So we could simplify it that way. Yes, you would get a fraction or a decimal. Leave it as a fraction. Make sure you still have your plus or minus. And then you would have the solution set -4 over 3 and +4 over 3.
Yes.
Let's do the same thing for 17. So we would add 1 to both sides. Oh, 17 wasn't. Oh, yeah, it was. Square equals 25. And then divide both sides by 4. Again, that's not something we can simplify. Pardon? Yeah. But when we take the square root of both sides, we could simplify it and take the square root of each part. When we take the square root, what fraction would we get?
5/2.
5/2. Plus or minus 5/2. So that would give us x equals negative 5/2 and positive 5/2. Let's try number 18. Same process, subtract 16 on both sides. And what would I do next? Put a divide, yes. Then what? If we take the square roots of both sides, what's going to happen? Someone try it. Put this in your calculator. See what you get.
Oh, next the square root negative.
So when we subtracted, we could have stopped right there. It's okay that you kept going as long as you realize somewhere you can't get an answer for this. Now, all the problems we've done so far have had perfect square roots to get us whole numbers or whole number fractions with the perfect square roots. Now we're going to deal with what happens if we don't have a perfect square. So for 19, this is already isolated, so we would just need to take the square root. 19 is not a perfect square, so when we do this, we're going to get a decimal. So you would put in your square root of 19. Whatever that is, right about 3 decimal places. So 4.359, you can round. And then we would do the negative and positive versions of that. So you're gonna get answers no matter what, if it's a perfect square or not. Some may be whole numbers, some may be fractions that come from perfect squares, or some may be just decimals. So because you can get all of those, be careful with how you solve, because you may think that you're getting the right answer, but you may not actually be. Okay, we're going to stop there for today and then pick this back up tomorrow.